Now, in this lecture, we'll find out the radius of a circle. In the drawing, we have a circle. Inside the circle, we have chord AC that is equal to square root of 2 units in its length. Chord DB equals to 2 units. In this angle DEB equals to 45 degrees. Our mission is to find out the radius of this circle. So we'll use two rules in order to find the radius. The first rule is that the central angle is twice as big as the peripheral angle resting on the same chord. Here we have, I'll repeat again on the rule, the central angle is twice as big as the peripheral angle resting on the same chord. So here the peripheral angle is angle ACB and it is equal to alpha, and it rests on chord AB. The central angle, this is the central angle, angle AOB, that rests on the same chord, chord AB. Therefore, according to this rule, the central angle AOB must be equal to 2 alpha, because the peripheral angle equals to alpha. Therefore, the central angle that rests on the same chord must be equal to 2 alpha. Okay, so the central angle is twice as big as peripheral angle that rests on the same chord. Okay, this is the first rule. And the second rule is the law of cosines. According to the law of cosines, in any triangle, this triangle ABC could be any triangle, and we know that side AB of triangle ABC equals to A units, side AC equals to B units in its length, and side BC equals to C units in its length, and this angle BAC equals to theta. Then, according to the law of cosines, C square equals to A square plus B square minus 2 times A times B cosine theta. Okay, C square equals to A square plus B square minus 2 times A times B times cosine theta. And from this equation, it is very easy to arrive to this equation, that cosine theta equals to A square plus B square minus C square over 2AB. Again, cosine theta equals to A square plus B square minus C square over 2AB. Okay. So in the next step, we will define the center of this circle, this point, as O. We join points O and B, points O and D, points O and A, points O and C by a straight line. Okay, and so we created there 4 line segments. All those 4 line segments that we created here are the radii of this circle. Why? Because of the fact that they start from point O, that is the center of the circle, and ends at points B, D, A, and C, that is the points on the circle itself. And this is exactly the definition of a radius. So all the 4 line segments are the radii of this circle. We define the radius of this circle as R, and therefore OB equals to R, OD equals to R, OA equals to R, and OC equals also to R. In the next step, we'll focus on the straight line AB at point E, here, this point, on the upper side of the straight line AB, we have this angle that is equal to 45 degrees. So in the upper side, the missing angle is angle AED. The missing angle must be equal to 135 degrees. Why? Because 135 degrees plus 45 degrees equals to 180 degrees, exactly according to rule number 1, that the sum of the angles on one side of a straight line is equal to 180 degrees. So the sum of the angles on the upper side of the straight line AB at point E equals to 180 degrees. Okay? We will define angle A, the peripheral angle ADC as y over 2. This peripheral angle ADC rests on chord AC, and it is equal to y over 2. Therefore, the central angle AOC that rests on the same chord AC, must be equal to y, according to the rule that I mentioned. Likewise, we define the peripheral angle DAB, this angle is x over 2. Peripheral angle DAB rests on chord DB. Therefore, the central angle DOB that rests on the same chord DB, must be equal to x, according to the rule that I mentioned. Okay? So, in the next step, we will focus on the green triangle AED. On the green triangle AED, the sum of the angles must be equal to 180 degrees. It is true in any triangle, therefore it is especially true in the green triangle AED. So which angles we have inside green triangle AED? We have angle x over 2 plus y over 2 plus 135 degrees must be equal to 180 degrees according to the rule that I mentioned. So here x over 2 plus y over 2 plus 135 degrees equals to 180 degrees. We subtract 135 degrees from this equation, and we will get that here we have x over 2 plus y over 2. This is the equation equals to 180 degrees minus 135 degrees is 45 degrees. Here we will multiply this equation by 2. 45 degrees times 2 is 90 degrees. X over 2 times 2 is x, y over 2 times 2 is y. So actually we found out that x plus y equals to 90 degrees. We subtract from this equation x, and we will get that y equals to 90 degrees minus x. Okay, y equals to 90 degrees minus x. In the next step, we will implement the law of cosines on the pink triangle DOB. On the pink triangle DOB, according to the law of cosines, cosine x equals to r squared plus r squared minus 2 squared. 2 squared is 4, so it is minus 4 over 2 times r times r. So actually, found out that according to the law of cosines, the pink triangle DOB cosine x equals to r squared plus r squared minus 4 over 2 times r times r. So actually, according to equation number 1, cosine x equals to r squared plus r squared is 2r squared minus 4 over 2 times r times r. 2 times r times r is 2r squared. So cosine x equals to, we'll split this expression into two parts. The first part will be 2r squared over 2r squared, and the second part will be minus 4 over 2r squared. So we found out that cosine x equals to 2r squared over 2r squared is 1. Here we have minus 4 over 2 is minus 2. So in the numerator we have minus 2 over, in the denominator we left only with r squared. So actually, according to equation number 1, we found out that cosine x equals to 1 minus 2 over r squared. In the next step, we implement the law of cosines on the yellow triangle AOC. In the yellow triangle AOC, according to the law of cosines, we get that cosine y equals to r squared plus r squared minus square root of 2 squared. Square root of 2 squared is 2, so it is minus 2 over 2 times r times r. So actually we found out that cosine y equals to r squared plus r squared minus 2 over 2 times r times r. So cosine y, according to equation number 2, equals to r squared plus r squared is 2r squared. 2r squared minus 2 over 2r times r is 2r squared. So cosine y equals to, we'll split this expression into two parts. The first part will be 2r squared over 2r squared, and the second part will be minus 2 over 2r squared. So according to equation number 2, cosine y equals to 2r squared over 2r squared is 1. Here we have minus 2 over minus 2 is minus 1, so in the numerator we have minus 1, in the denominator we left only with r squared. Okay, so cosine y according to equation number 2 equals to 1 minus 1 over r squared. So we have only found out that y equals to 90 degrees minus x. So we substitute y in this equation number 2 by x. And we will get that cosine y is 90 degrees minus x, so cosine y is 90 degrees minus x, and cosine 90 degrees minus x is sinus x. So in conclusion, we found out that cosine y equals to sinus x. Write it down. Again, cosine y equals to sinus x, and therefore we substitute cosine y in equation number 2 by sinus x. So in equation number 2 we have cosine y, so cosine y is sinus x is equal to 1 minus 1 over r squared. So we found out that according to equation number 2, sinus x equals to 1 minus 1 over r squared. And according to equation number 1, we have already found out that cosine x equals to 1 minus 2 over r squared. It is actually cosine x equals to 1 minus 2. It is, we multiply here it by 1. When you multiply something some expression by 1, it does not change the value. So it is allowable to do it. Multiply this side and this expression by 1. In the next step, we'll define 1 over r squared as t and we will substitute 1 over r squared in both equations, equation number 1 and equation number 2, by t. And we get that according to equation number 2, sinus x equals to 1 minus 1 over r squared is t, so we substitute 1 over r squared by t. So actually, according to equation number 1, we found out that sinus x equals to 1 minus t. We do the same operation in equation number 2. According to equation number, we do the same operation in equation number 1. In equation number 1, we have cosine x equals to 1 minus 2 times 1 over r squared. 1 over r squared is t, so we substitute 1 over r squared by t, and we get that in total, according to equation number 1, cosine x equals to 1 minus 2t, while according to equation number 2, we found out that sinus x equals to 1 minus t. Okay, in the next step, we use the trigonometric identity that says that sinus square x plus cosine square x equals to 1. Okay, so we implement this trigonometric identity in our two expressions for sinus x and cosine x. So here we have sinus square x. Yes, so sinus x is 1 minus t, therefore sinus square x is 1 minus t squared. This is equation number 3. Plus cosine square x. Cosine x is 1 minus t, therefore cosine square x is 1 minus 2t squared equals to 1. So in conclusion, we found out that according to equation number 3, 1 minus t squared plus 1 minus 2t squared equals to 1. We'll open the brackets of this side of equation number 3 and we get that according to equation number 3, 1 minus t squared equals to 1 squared, that is 1, plus t squared minus 2t. We'll open the brackets of this expression and we'll get that 1 minus 2t squared equals to 1 squared, that is 1, plus 2t squared, that is 4t squared, minus 2 times 2t is minus 4t, equals to 1. So here we have t squared plus 4t squared is 5t squared. Minus 2t minus 4t is minus 6t. Here we have 1 on both sides of the equation, so 1 will get cancelled. And we're left only with this one, so it is plus 1 equals to 0. In the next step, we will substitute minus 6t by minus 5t minus 1t. And we'll get that according to equation number 3, five t squared minus 16. 60 is minus 5t minus 1t. And we have here plus 1 equals to 0. Okay, here, according to equation number 3, 5t squared minus 5t minus t plus 1 equals to 0. In the next step, we will take out 5t as a common factor from those two expressions. Okay, so here we have 5t was taken out as a common factor. So what is left from 5t squared after we took from it 5t as a common factor? What is left is actually t. And what is left from minus 5t after we took from it 5t as a common factor? What is left is actually minus 1 plus, in the next step we take out minus 1 as a common factor from those two expressions in the yellow color. So minus 1 was taken out as a common factor. So what is left from minus t after we took from it minus 1 as a common factor? What is left is actually t. What is left from plus 1 after we took from it minus 1 as a common factor? What is left is actually minus 1. Equals to 0. In the next step, we take out t minus 1 as a common factor from those two expressions. So t minus 1 is taken out as a common factor. So from those two expressions, so what is left from 5t times t minus 1 of every 2 from it, t minus 1 is a common factor. What is left is actually 5t. And what is left from minus t minus 1 after we took from it t minus 1 is a common factor. What is left is actually minus 1 equals to 0. So here we have two solutions that are possible for t. Either t minus 1 equals to 0 or 5t minus 1 equals to 0. We start with the first possibility, that t minus 1 equals to 0. So if t minus 1 equals to 0, it means that t equals to 1. And according to our definition, t equals to 1 over r squared. So we substitute t by 1 over r squared here in this equation, and we get that t is 1 over r squared. It is equal to 1. We multiply this equation by r squared, and we get that r squared equals to 1. We take a root from this equation, and we get that r equals to plus minus the square root of 1. The negative square root of 1 is minus 1, so r equals to minus 1. The second possibility is that r equals to the positive square root of 1, that is to say r equals to plus 1 units. And because of the fact that r is a length, and the length must be a positive number, r cannot be equal to 1. So we cancel the solution, and we left only with the solution that r equals to 1. So we focus on the second solution, that 5t minus 1 equals to 0. We'll add 1 to this equation, and we'll get that 5t equals to 1. We'll divide this equation by 5, and we'll get that t equals to 1/5. T equals to 1/5. And according to our definition, t equals to 1 over r squared. So we substitute t in this equation by 1 over r squared. We get that t is 1 over r squared. Then it is equal to 1/5. We cross multiply this equation, and we get that r squared equals to 5. R squared equals to 5. We take root from this equation, and we get that r equals to plus minus the square root of 5. So r cannot be equal to the negative square root of 5. Why? Because r is a length, and the length must be a positive number. Therefore, we cancel this solution. R cannot be equal to the negative square root of 5. Therefore, we left only with the second solution, that r equals to the positive square root of 5. So we have two solutions that are possible for r, the radius of the circle. Either it is equal to square root of 5, or r equals to 1. In the next step, we will focus on the drawing. We have chord dB equals to 2 units, and it is very easy to see that chord dB doesn't pass for point O, that is the center of the circle. And therefore dB is not the center of the circle. Why? Because therefore chord dB is not the diameter of the circle. Why? Because any diameter of a circle must pass through the center of the circle, must pass through point O. And because of the fact that chord DB doesn't pass through point O, it is not the diameter of the circle. DB is not the diameter of the circle. And we also know that the diameter of any circle is the longest chord in the circle. Therefore, the diameter 2R is greater than dB, that is not the diameter of the circle. So I write it down. Here, the diameter of the circle, that is 2R, that is the longest chord in the circle, must be greater than dB, that is not the diameter of the circle. Okay, and according to what is given us in the question, dB equals to 2, so we substitute dB by 2 in this inequality, and we'll get that 2R is greater than dB, that is 2. We will divide this inequality by 2, and we will get that R is greater than 1. So the solution that R equals to 1 is not possible, is not true, is not correct, because R must be greater than 1. So we're left only with the second solution, that R equals to the square root of 5. Or in terms of numbers, it is equal to 2.236 units. Okay, this is the answer to the question. I repeat again. The radius of this circle R equals to either square root of 5 units, or in terms of numbers, it is equal to 2.236 units. In the next step, I will summarize the lecture. So in the drawing, we have a circle, chord DB equals to 2 units, chord AC equals to square root of 2 units in its length, and this angle equals angle DEB equals to 45 degrees in its size. Our mission is to find out the radius of this circle. We use two rules in order to find out the radius of the circle. The first rule is that the central angle is twice as big as the peripheral angle resting on the same chord. I'll repeat again on the first rule that we used. Here, the central angle is twice as big as the peripheral angle resting on the same chord. Here we have chord AOB that is equal to alpha, and it rests on chord AB. And we have the central angle AOB that rests on the same chord AB. And according to this rule, the central angle AOB must be equal to 2 alpha. Okay? Because of the fact that the peripheral angle AOB equals to alpha, the central angle AOB must be equal to 2 alpha. Why? Because both of those two angles are resting on the same chord. So always the central angle is twice as big as the peripheral angle that rests on the same chord. This is the first rule that we use. And we also have the second rule, that is the law of cosines. The law of cosines is true in any triangle. So this triangle ABC could be any triangle. The length of side AB is A unit. Side AC equals to B units in length, and side BC equals to C units in length. Angle BAC, this angle equals to theta. Then the following equation is true according to the law of cosines. C square equals to A square plus B square minus 2 times A times B times cosine theta. Okay, so from this equation, it is very easy to arrive to this equation, that cosine theta equals to A square plus B square minus C square over 2 times A times B. Again, cosine theta equals to A square plus B square minus C square over 2 times AB. So here we define the center of this circle as O. Then we join points O and B, O and D, O and A, and O and C by a straight line. So we created here 4 line segments, OB, OD, OA, and OC. All those 4 line segments are the radii of this circle. Why? Because they start from the center of the circle, that is to say from point O, and ends at points B, D, A, and C. All those 4 points are on the circle itself. And any line segment that starts from the center of the circle and ends at any point of the circle must be the radius of the circle. Therefore, all those 4 line segments are the radii of this circle. We define the radius of this circle as R, therefore OB equals to OD equals to OA equals to OC equals to R. They are all the radii of the circle. Then we focused on the straight line AB. This straight line AB at point at the up and at point E, at the upper side of point E. Which angles we have here? We have this angle that is equal to 45 degrees. So the missing angle must be equal to 135 degrees according to the rule that the sum of the angles on one side of a straight line equals to 180 degrees. That is to say, the sum of the angles on the upper side of the straight line of any straight line equals to 180 degrees, and especially the straight line AB. Why? Because 45 degrees plus 135 degrees equals to 180 degrees, exactly according to the rule number 1. Okay, then we focused on we defined the peripheral angle CDA is y over 2. Peripheral angle CDA is equal to y over 2 rests on chord AC. Therefore, the central angle AOC that rests on the same chord AC must be equal to y. Then we defined peripheral angle DAB that rests on chord DB is x over 2. Therefore, the central angle DOB that also rests on chord DB must be equal to x, according to the rule that I mentioned. Then we focused on the green triangle AED. The green triangle, in any triangle, the sum of the angles must be equal to 180 degrees, and especially in the green triangle AD. Which angles we have here? X over 2 plus y over 2 plus 135 degrees must be equal to 180 degrees. Repeat again. X over 2 plus y over 2 plus 135 degrees must be equal to 180 degrees. We subtracted 135 degrees from this equation and found out that x over 2 plus y over 2 equals to 180 degrees minus 135 degrees is 45 degrees. Then we multiplied this equation by 2 and found out that x plus y equals to 45 degrees times 2 is 90 degrees. Okay, I'll repeat again. X over 2 times 2 is x, and y over 2 times 2 is y, and is equal to 45 degrees times 2 is 90 degrees. So x plus y equals to 90 degrees. We subtracted x from this equation and found out that y equals to 90 degrees minus x. Okay, then we implemented the law of cosines in the triangle DOB. According to the law of cosines, cosine x equals to r squared plus r squared minus 2 squared over 2 times r times r. Repeat again. In the triangle DOB, cosine x equals to r squared plus r squared minus 2 squared, that is 4 over 2 times r times r. So cosine x equals to r squared plus r squared, that is 2r squared minus 4 over 2 times r is 2r squared. So cosine x equals to, we split this expression into 2 parts. The first part is 2r squared over 2r squared, and the second part is minus 4 over 2r squared. So cosine x equals to 2r squared over 2r squared is 1. And minus 4 over 2 is minus 2. So in the numerator we have minus 2, and in the denominator we left only 4 squared. So according to equation number 1, cosine x equals to 1 minus 2 over r squared. Then we implemented the law of cosines on the yellow triangle AOC. According to the law of cosines, cosine y equals to r squared plus r squared minus square root of 2 squared. Square root of 2 squared is 2. So here it is 2 over 2 times r times r. Repeat again. according to the law of cosines in the yellow triangle AOC, cosine y equals to r squared plus r squared minus 2 over 2 times r times r. So cosine y equals to r squared plus r squared is 2r squared minus 2 over 2 times r is 2r squared. Okay, then we split this expression into two parts. So we have here cosine y equals to, the first part is 2r squared over 2r squared, and the second part is minus 2 over 2r squared. So actually found out that cosine y equals to 2r squared over 2r squared is 1, and here minus 2 over minus 2 is minus 1. So in the numerator we have minus 1, in the denominator we have r squared. So according to equation number 2, we found out that cosine y equals to 1 minus 1 over r squared. When according to equation number 1, cosine x equals to 1 minus 2 over r squared. So we have already found out that cosine that y equals to 90 degrees minus x. Therefore, you can substitute y in this equation number 2 by 90 degrees minus x. We did it, and we got that cosine y is cosine 90 degrees minus x, and cosine 90 degrees minus x is sinus x. So in conclusion, we found out that cosine y equals to sinus x. Hit again here. We found out that cosine y equals to sinus x, therefore we can substitute cosine y in equation number 2 by sinus x. So this is equation number 2. Cosine y equals to 1 minus 1 over 1 minus 1 over r squared. So cosine y is sinus x, so we get that sinus x equals to 1 minus 1 over r squared. Repeat again. I found out that sinus x, according to equation number 2, equals to 1 minus 1 over r squared. And we have already found out that according to equation number 1, cosine x equals to 1 minus 2 over r squared. Then multiply it by 1. It is allowed to multiply everything by 1 because it doesn't change the expression. Then we defined 1 over r squared as t, and we substituted 1 over r squared in those equations, equation number 1 and equation number 2, by t. So in equation number 2 we have sinus x equals to 1 minus 1 over r squared. 1 over r squared is t, so it is sinus x equals to 1 minus t. Sinus x equals to 1 minus t. And then we have equation number 2, cosine x equals to 1 minus 2 times 1 over r squared. 1 over r squared is t, therefore this expression in total is minus 2t. So we found out that according to equation number 1, cosine x equals to 1 minus 2t. Repeat again, cosine x equals to 1 minus 2t according to equation number 1, when according to equation number 2, sinus x equals to 1 minus t. Then we have the trigonometric identity that sinus square x plus cosine square x equals to 1. So we created this trigonometric identity in our two equations that are the expressions for sinus x and the expressions for cosine x. So here we have sinus square x. Sinus x is 1 minus t, therefore sinus square x is 1 minus t squared. Cosine plus cosine square x. Cosine x is 1 minus 2t, therefore cosine square x is 1 minus 2t squared. Okay, here, so we have here 1 minus t squared plus 1 minus 2t squared equals to 1. It must be equal to 1, according to this trigonometric identity. Then we open the brackets on this side of equation number 3, and we found out that 1 minus t squared equals to 1 squared, that is 1, plus t squared minus 2t, plus 1 minus 2t squared equals to 1 squared, that is 1, plus 2t squared, that is 4t squared, minus 2 times 2t is minus 4t equals to 1. Here we have t squared plus 4t squared plus 4t squared is 5t squared, minus 2t minus 4t is minus 6t, and we have here 1 in both sides of the equation, so 1 will get cancelled and we're left only with this one. So here we will have 5t squared minus 6t plus 1 equals to 0. Then we substitute minus 6t by minus 5t minus 1t, and we found out that five t squared and minus 6t is minus 5t minus 1t plus 1 equals to 0. Then we took out 5t as a common factor from those two expressions that are in the green color. So inside the brackets we left only with t minus 1. Then we took out minus 1 from this expression that is in the yellow color. So inside the brackets we left with t minus 1 equals to 0. Then we took out t minus 1 as a common factor from those two expressions. So inside the brackets we left with 5t minus 1 equals to 0. So here we have two solutions that are possible for t, for the value of t. Either t minus 1 equals to 0 or 5t minus 1 equals to 0. So if t minus 1 equals to 0, it means that t equals to 1. And according to our definition, t equals to 1 over r squared. So we substitute t by 1 over r squared. So 1 over r squared, t is 1 over r squared, that is equal to 1. Multiply this equation by r squared and found out that r squared equals to 1. Okay, we took out of this equation and found out that r equals to the plus minus of the square root of 1. R cannot be equal to the negative square root of 1. The negative square root of 1 is minus 1. R cannot be equal to minus 1 because R is a length and the length must be a positive number. Therefore, R cannot be equal to minus 1. So we cancel this solution and we left only with the second solution that R equals to the positive square root of 1. The positive square root of 1 is 1. So R equals to 1. Then, according to the second solution, 5t minus 1 equals to 0. We added 1 to this equation and found out that 5t equals to 1. We divided this equation by 5 and we found out that t equals to 1/5. And according to our definition, t equals to 1 over r squared, so we substitute t by 1 over r squared in this equation. So here we have t that is 1 over r squared equals to 1/5. We cross multiply this equation and found out that r squared equals to 5. We took out of this equation and found out that r equals to plus minus square root of 5. R cannot be equal to the negative square root of 5 because r is a length and the length must be a positive number, therefore r cannot be equal to minus square root of 5. So we cancel this solution and we left only with the second solution that r equals to the positive square root of 5, or we have also the other possibility that r equals to 1. Then we focused on our drawing. In our drawing, dB equals to 2 units. In its length, it is very easy to see that dB doesn't pass for point O, therefore dB is not the diameter of the circle. Any diameter of a circle must pass for point O, and because of the fact that dB doesn't pass for point O, it is not the diameter of the circle. And we also note that the diameter of any circle is the longest chord in the circle. Therefore, the diameter 2r must be greater than dB, that is not the diameter of the circle. Very simple. Okay? So, the diameter 2r of the circle must be greater than dB, that is not the diameter of the circle. So, we have this inequality. We substitute in this inequality dB by 2 according to what is given us in the question. dB equals to 2. So here dB is 2. And so we have in this equality 2r is greater than 2. We divided this inequality by 2 and found out that r is greater than 1. Therefore, r cannot be equal to 1, because r must be greater than 1. So we cancel this possibility, the solution, and we're left only with the second solution that is possible, that r equals to the square root of 5, or in terms of numbers, it is equal to 2.236 units. I repeat again, the radius of this circle r equals to either the square root of 5, or in terms of numbers, it is equal to 2.236 units. Okay, thank you very much.